should be live in the kitchen. Yeah. Okay, so now that I got the cat out of the way over there, see if I can get the screen a little bit more in frame. Oh, but you're gonna miss the cat. We'll leave the cat in there. She wants to know what's going on. Okay, she wants to feel included. All right, so speaking of, there's some cat food right there on the computer desk. Yeah. So did some more overclocking today with the EVGA GTX 690 Hydro Copper, and got a best run score in Firestrike. Are you gonna turn wrenches now, Cat? Of blue screen to death, basically, and that is the CPU overclock. I am on the absolute ragged edge of what my CPU, I've got it clocked at 5.1. Just for this project, I'm letting the voltages go higher than I normally would, but it is still, like, I have the low line calibration set not to the most aggressive, but to what I think is pretty freaking aggressive. It's like level 2. Level 1 is max, and I'm at level 2. I'm one off of the max. So I'm just going to go ahead and set this at 1.37. It doesn't like that. Well, 1.35. How about that? How about 1.35? I think that's 1.35 is max. Yeah, that's the max it'll let you go before it gets red and tells you, like, hey, buddy, your cooling solution is. So I'm going to go from, so slightly. I did get one complete run in at 1.335, which actually, once you get, that's 1.335 set, but actually what you wind up getting is 1.34. So I'm going to jump 1.34 and go to 1.35 and see what that gets me. But single card, no quad fire. This is just one. It's two 680s in SLI, two 680s basically in SLI. I got a max score Firestrike of like 13,600 and change, right? Which is pretty good. So compare that to this card with just some really, superficial overclocking and not as high an overclock. I think I was at 5 gigahertz all core when I was benchmarking this, and I didn't have my memory speed or my uncore or ring, whatever you want to call it, bumped up either. Now I've got the uncore at 4.8 gigahertz, and I've got the CPU at 5.1, so that's like a 3% or a ×3 offset between the two, and that's about what MSI, the maker of the motherboard, suggests that you do. So this got about 8,000 points, just a little bit over 8,000, doing some pretty superficial overclocking, nothing too intense, on air, not on water. So we're not even getting double scaling, right? And I didn't think we would. I never thought we would, really. We're getting like, mental math, I think about 65% scaling by adding an additional GPU. Now, one thing that this card does have going for it over this card is this single GPU's got access to 4 gigabytes of DDR4 memory, whereas those two GPUs are splitting 4 gigabytes, 2 gigabytes each, and they don't ever get to pool it all together, really. It's basically just 2 cards doing their own thing, and they have like a sync controller kind of bridge program in the middle in between them. So yeah, so we went from 13 or we went from 8,000, basically just a shade over 8,000 to 13.6. So that would have been, so a true doubling, you know, would have been 16,000 and change, and we didn't get that. So we got 13,600, and that's, we're getting like really like a little bit of artifacting in the benchmark. So I know I'm on the ragged edge. I don't think there's another bin step that I can get up on either the core or the memory. I've kind of like walked them both back and forth, done a little seesaw to try to figure out where the fine edge is. And I can get both of those cards to run non-stop at 1215 megahertz. And I run the memory at like 3600 megahertz, I want to say. That's about as far as I can get. And it's not temperature related. That is just the silicon quality, right, of both the memory modules and the GPUs themselves, the silicon quality of the GPUs themselves. The GPUs never crest above 30 degrees. 29 degrees I saw one time. Typically they max out at 28 degrees Celsius on the back end of a run. So I know I'm not running out of cooling with the sink, the insinkerator, right? That's probably trademarked and I'll get copyright strike for saying that. Yeah, the sink is definitely doing really well. You know, it's an inexhaustible supply of cool water, so it's obviously going to be any kind of custom loop that you can throw at it. It's so these idle at what my room. These idle directly at what my ambient room temperature is, maybe like 1 degree Celsius above it. It's about 20 degrees Celsius in the room right now, and they typically idle right at 20 degrees Celsius. So if this will let me into my results. No results yet, you got to go to your damn, got to run one. So let's run one last one. See if 5.1 gigahertz at 1.35 volts is stable. So I got 5.1 gigahertz on the CPU. The memory's running at 3833, which is like a little bit above its stated XMP, and I've tightened the timings down to 14, 14, 14, 34, and I took whatever that last number is, it's like 600 and some. I've got it down to like 350. So that's pretty good. I've tightened those timings down a lot. Uncore's at 4.8, and we'll let it run and see what we get here. Let's make sure my live stream is still going. Yep, running at 480 as per usual. I guess I don't know if I'm alone in the house right now. There's nobody in here, so I'm not competing with Wi-Fi bandwidth for anybody. See, I see that one little flicker right there. I don't know if it comes through on this shoddy resolution you guys are having to watch the stream on, but this is going to be a quick one. So we're going to finish this loop. I'm going to tear it down, and then we're going to add an additional EVGA signature GeForce GTX 690 Hydro Copper. And I have the SLI bridge there, ROG Republic of Gamers SLI bridge. We'll see if this actually works. That's one of the many downfalls of running SLI CPUs is these bridges are cheap, chintzy, notoriously fragile. They don't work more often than not. Seems like I have, I don't know, every modern motherboard in the last 7 or 8 years seems to come with one version of these or another, and a lot of them aren't very good. This is definitely the HBM or the HB high bandwidth version of this for SLI is light years better than this solution, and then NVLink is obviously, again, you know, if you watched the kickoff for, you know, SLI is dead, long live SLI, or not EVGA, NVIDIA basically got to a point where the SLI bridge, if you want to call it that, NVLink, whatever they're calling it, is now so good that the actual two separate GPUs can pool memory resources over the allowed bandwidth in that connection point. But they've gone and killed it, basically. They finally got the technology to where, you know, it would be possible for game developers to use it, or you know, AI modelers, you know, anybody who needs their GPUs to be able to share massive amounts of RAM cache. Yep, 13615. So that I think is going to be my best one. Let's see where it stacks up. Yep, 13615. That is my best run to date on this single GTX 690. We got like I said, all the specs of the 10600K dialed in. I don't think that in this particular setup that I will ever be able to beat the single GTX 690 record of I think it's 15,000. So I'm about 1,400 points off of the record. I would need, I probably need a hacked BIOS, and I would probably need a chiller or something to get the water like sub ambient, like 0 degrees. So like a cooler with ice, some kind of, you know, radiator to run it through to pre-chill it before it hits the GPUs. I need some kind of concoction, which I'm working on. That's in the future. I will get there. But right now, I'm going to say that this is good enough. Oh, and one of the other reasons why it's going to be really hard to catch that 15,000 score is that joker is running a GTX 690 on an Intel 10980XE. So if you don't know what that is like Intel's extreme high-end desktop CPU line. It's got I want to say it's 18 core. So it's 3 times more cores, plus it's hyper-threaded. I'm pretty sure it's 18 core, 36 thread. So it's 3 times more powerful theoretically. It doesn't scale quite like that. But his physics score, like I'll just show you, like my physics score is 22,762, which is respectable. And then how do I get to his physics score? I'm going to hardware bot. And then, let's see, GTX 690, GeForce GTX 690. Hardware bot's website is pretty slow, a lot like my brain and my speech. Hardware bot pretty slow. Let's see, 3D Mark, Fire Strike. Yeah, 14. Oh, I'm sorry, not 14.4, 14.5, basically. So how far away am I from that? He's at 14.5. I'm at 13.6. So 900 points. I guess that's theoretically in the realm of possibility for me to catch, but yeah, he's running. Oh, not a 10980. He's running a 7980XE Skylake X on chilled water. So he's pushed that to 5.2 gigahertz. So he's got I don't 7980XE. I don't remember how many cores that is. Let's look that up. 7980XE is expensive. $650 on eBay. Let's see. The Intel Core i9 7980XE Skylake X is 18 cores, 36 threads. So yeah, it's 3 of mine, and he's got it running 100 megahertz faster than mine, and doesn't say how much RAM he's got or what he's running it at. Oh, it's right here in the screenshot though. Let's see. What's he got? What's his CPU Z? He's running 5,241 megahertz. He's got 32 gig of memory in quad channel. His DRAM frequency is 4200. So he's got double the amount of memory, and he's running it 200 megahertz faster than me, and that's why he's like absolutely crushing me on the physics score. He's got a 37,000 physics score, and I've got a 22,000. But I'm only 800 total points behind. I've got a 16,494 on the graphics, and he's got a 16,931. So I'm pretty close on graphics actually. But man, the amount of the gap on our physics score is probably insurmountable to what I got going on. You know, I don't have Skylake X. I don't even know what platform that is. It's definitely, I don't have the money to be an Intel HEDT guy. Just something I have no frame of reference for. Let's see. Does it say what's this is a LGA 2066? Yeah. So you can get one on eBay for $650. It's a steal at twice the price. Man, that is like that CPU costs more than almost this entire rig. That's pretty crazy. So it'd be tough to beat that. Yeah. So I'm not going to try. I'm going to go straight to Quad SLI and see what I got going on there. Okay. So we're going to close this out. We're going to shut this loop down. We're going to tear it all down, and I've got to replumb some of it. So let's shut down. Okay. All right. So because of the way these blocks are designed and the hose barb fittings that I'm having to use, and I don't have like I don't know if they even made a link. You know, sometimes you can get like a hard link that's got a certain PCIe spacing to link two cards together. I don't have a link, so what I'm going to have to do is I'm going to have it go in on this side of, so I'm going to reverse the flow on this card. It doesn't really matter. In on this side, out on both on the back side, come out here, loop up and over and into the front of this, and then out the front of this also, and out into the sink. And that way I've got the hose barbs pointing away from each other on both sides. Otherwise they won't fit on the motherboard. The hose barbs will be like interfering with each other because they're too long. If I had shorty hose barbs, low profile hose barbs, I could probably jerry rig up like a little, clear hose bridge between the two of them. But yeah, the barbs are too long for that. These are O-Cool or OX Cool. I'm not really sure. Alpha Cool. Alpha Cool. Let's just go with that. These are Alpha Cool. Yeah, I don't know. I guess that's supposed to be an alpha symbol there. I'm not Greek, so Alpha Cool hose fittings. They're HF 10 millimeter 3/8 inch with an O-ring, and they're in German. Mit O-ring. Fat boy, they call them. That's appropriate. That's why I like them. Fat boy hose fittings for the fat boy's computer. All right. Let's put these over here. All right. Let's get this guy off of, oh, let's unplug that. Let's also just turn off all the board power. So I hope, hope is not a planning factor, but you know, I did it anyway. I'm going this route anyway. I hope that my power supply is beefy enough to sustain this level of power output to these two cards. I guess we're just gonna send it. That's how I usually do stuff. Just gonna send it, and we'll find out. You know, that's how we're gonna roll. As I spill water all over the place, and I don't have any paper towels. I meant to bring paper towels down here to do this. Totally forgot. So there's that. Oh wait, hold on. This one stays. These are the ones that I don't have. So I don't know how many of you guys do water cooling. So what we're gonna do, so you gotta, most GPUs that are water blocks come with a header block on the top, right? So you've got the full coverage water block here that's actually making contact to the video card that's sandwiched in here. But you've got a hose barb, or you've got ports, 2 ports on either side, right? And these go straight through. It's to give you the ability to do what I'm about to do right now, which is decide which side of the GPU you want the water to enter into, right? So right now, the way I had it set up, water was entering in here. It would go, it's blocked here. This is solid. Under this EVGA piece right here, there's solid acrylic or metal or whatever. Water enters here. It goes down into chambers that have micro fins made of copper that radiate the heat into the water. The water absorbs the heat, comes up out this hose barb, and then ejects into the sink the way I have it set up right now. So what I want to do is I want the water to come in on this side. I'm going to block this side because I have a little blocker plug right here, right? So I'm going to flip these, have this go this way. Water's going to come in probably here, I think, actually, and then go down through the block in reverse, which it doesn't really matter as long as water's flowing through the block. I've never heard of a block that was directional. Correct me if I'm wrong. And then eject out this way, right? So yeah, I've got to get this plug on basically. So the plugs that came with the EVGA, well, I don't know if they actually came with the EVGA. They were with it when I bought it. I don't know what was original from EVGA. Well, that's a pretty crushed washer. Hopefully that doesn't leak. And the hose barbs that I'm using from Alpha Cool do not, oh wait, this is the one I've been using, so I know it doesn't leak. They don't use the same size hex. This is a 15 millimeter. The plugs are 16 millimeter. Thankfully, I own an Audi, so I had lots of 16 millimeters around. It's actually really hard to find one of my 15 mils, which 15 mil is like pretty standard. A lot of times though, if you go buy like you know, a Walmart or a cheap brand of wrenches or sockets, they'll go 15, 17, and you won't get a 16. Ask me how I know, because I went and bought a bunch of cheap wrenches and sockets when I was a young man, and then I bought an Audi and couldn't work on it because I didn't have any 16 mils. That was a life lesson. Just gonna give those a little torque there. Okay, so first step is done. So this one, let's see. So that's my drain tube. So this is the feeder tube, and I want it to go in here, right? And now I need to cut another length of tubing to loop around my GPUs here. So I want this to be fairly large and be pretty easy. I don't want any kinks, so it's gonna look funky, but you know what? It already all looks pretty funky, so no harm there. Okay, so that should work. Gonna put this on here and put it in place. All right, stay with me. Okay. All right. One in. What in the heck is that? This guy had some kind of DVI to HDMI adapter. Will this just slide through maybe? Hopefully. Alright. And success. Alright. So that one is in also, and we're going to loop this around to the inlet here. Now, one thing I haven't done is leak checked this second card. Oh my lord, why am I like this? Okay. So that all looks legit. And then attach that. Okay, I don't have anything turned on. There's no electricity, so if something leaks, actually I'm gonna cut the electricity all the way back, right? So power supply switched off, the freaking distribution box is switched off. Going to cycle the power buttons. Make sure there's nothing. Okay, so I did all that because if this does leak and I get water on my motherboard, it's not the end of the world, right? There's no electricity flowing through here. There's no electricity flowing. The PSU is not even connected to the GPUs, right? So everything should be fine. I'm just going to fire this up. I'm just going to send it. And I don't see any leaks. Got some air bubbles in there. This second card, when I was swapping its hose fittings before the stream started, It had some, it looked like it must have been in a loop that was using, what do you call that? Like pastel, like a pastel purple fluid or something. It was not good. Definitely had some corrosion, or not, but like crusty buildup from the colored fluid. So let's turn the pressure up a little bit. Yeah, let's get those air bubbles out of there. Get them out, get them out. Okay, so that's all working well. I see no leaks. Got good flow. There's no water on the board anywhere. Okay, turn the water off there. That does, I need to do something about that. When the water pressure comes up in that tube, it moves it, and I don't want it moving it and causing it to spring a leak, possibly. So, while I think about engineering a solution for that, let me tell you what happened was, on the stream last night, I went to plug in this card. I went to plug in an HD 6970, and this motherboard said nope. It rejected it, and I had no idea what was happening. Seriously, I had no idea what was happening. So this is actually getting interference from this. Hopefully that makes a good enough PCI connection. Sorry, I got distracted there. Squirrel. So yeah, typically on modern motherboards, you know, motherboard manufacturers build into their BIOS a function that allows the UEFI to utilize a older GPU that doesn't have what they call a UEFI GOP, graphic output, right? So the BIOSes on these cards, because you know GPUs have their own BIOSes, are not UEFI BIOSes, so they don't have UEFI graphic outputs built in. Now there is a tool that EVGA made, and I am going to do this later, that will insert a UEFI like partition for a UEFI graphic output into these older 6 and 500 series cards. So I am going to do that with these. But what I didn't realize was that this motherboard is so new, it's on BIOS revision 1, that it did not have the capability to run in legacy mode in the BIOS. It just simply wasn't there. There was no legacy graphic card support in the BIOS of this motherboard. Most modern motherboards have that already in the baked into the sauce, right? So I went in, I found the latest BIOS. Was actually, since this motherboard was manufactured, there's been three or four BIOS revisions. I downloaded the latest one. It was supposed to help with legacy support. Was like the first thing it mentioned was support for, it's called CSM. It's a command service module, security module. I don't remember what that stands for. But so basically it all comes, it's all about like boot security or whatever. So if you enable a legacy mode, evidently your secure boot is disabled. So I got the new BIOS, I flashed it, I enabled the legacy graphic support, and voila, voici, these ran. And then I sat here for the rest of the evening overclocking them. I wasn't going to restart the stream. I know people got things to do, so you know, if you haven't finished binging, you know, Cobra Kai or whatever that show's called. I know you probably had to get up to that. So I got these. I got the 690 working with the legacy BIOS, which means I should be able to get the 6970 and the 6990 working with the legacy support in the BIOS. And now I've got quad SLI GTX 690s sitting on my motherboard, and it's a problem because they don't sit flush. Oh, I hope that makes good enough contact. So what's happening here is I've got a stack of SATA connectors, double stack SATA connectors over here, and this card is really low. It sits really low on the board. I don't know if that's just, you know, their aesthetic or whatever, but geez, oh Pete, I hope it gets a signal. So now we got to wire these in to the power supply. We're running an EVGA 1300 G2, and this Supernova 1300 Supernova G2 is a gold rated power supply, 1300 watts. Whew, I hope it's enough, man. There's enough money, I'll tell you that. Jeez, oh Pete, there's enough money. All right. So I'm gonna give. You know, I don't know. I haven't even really even looked at the pinouts on this power supply. Should probably do more homework, but I don't know how this is configured on, you know, if there's more than one rail that feeds PCIe power on a 1300 watt PSU. I would hope that there is, but, you know, I'm not sure. So do I have one of these that's not got the SATA VGA? Yeah. So I'm not gonna need these two here as long as I can get to VGA 3. Alright, so I hate these ones that have double pigtails in them. I just don't like that. Is this light blinding you guys? Let me just turn that off, that way you guys can see a little better. Okay. So I got quad 8-pin power connectors to quad GTX quad SLI GTX 690s. Will it work? I have no idea, honestly. I've never plugged this second card in my life. Big shout out to Der Bauer though for the sink water cooling idea. Holy crap. That is a lifesaver, because, you know, I had kind of, done a bunch of back of the envelope, back of the napkin sketches of what a desktop, water cooling setup rig would look like for this. It was scary. So, this is way more better. Okay, so we're going to turn the power back on at the distribution box, power back on the power supply, and start the water flowing. Still like some air bubbles in there. And hit the go button. Ooh, we got 4, oh, false start. What does it tell me? It doesn't tell me anything because I don't have a damn output display cable plugged in. If you want to know what your computer's doing, you have to plug in a display cable. It's mandatory. Anything? Any display output at all? No signal. I'm wondering if the lack of contact on this PCIe port is going to be an issue. It's like in there as far as I can tell, but I can just see there's like a millimeter of difference between the height at the end of this GPU and the height at the end of that GPU. Just seems to be a little bit different. And it's locked in. It's just what do my debug LEDs tell me? VGA. No bueno. Doesn't like it. Oh, something happened. Something came up there. Ooh. Let's see. PCI resource error. PCI out of resources condition. Error. Insufficient PCI resources detected. System is running with insufficient PCI resources in order to display the message. Some PCI devices were set to a disabled state. Oh, you know what? Son of a gun. So I'm gonna have to go back and read the manual on this motherboard, but I think because I have the SSD here in this bottom slot, this bottom M.2 slot instead of the top M.2 slot, that it's competing with resources with this second GPU. Yep, that is going to be the problem. That is going to be the problem. So, I'm going to turn that off. Turn that off. Now, whew, Lord, make me nervous. I don't really want to do this, but it looks as though I don't have a whole lot of a choice. I'm gonna have to move and maneuver this graphics card that's full of water and is made out of a solid block of copper, cooling plate, etc., out and away from this little heatsink right here that's holding my M.2 drive, and move my M.2 drive to the M.2 drive that's down here, because of PCIe Express, PCIe lane resource constraints. That is no fun. Let me go look at the manual here. This is why I wanted to use Threadripper. All right, so let's get to ground truth. I got my MAG Z490 Tomahawk user guide, and I'm gonna have to go through here and find where it tells me about PCIe expansion slots, etc. Page 28. All right. So, oh, that's a by 4 also. I did not realize that. Well, this is not PCIe 3, I don't think. GTX 690 is PCIe 2.0 anyway. M.2 keys. So there's 2. Intel RST only supports PCIe M.2 Octane. No? Let's see. No, so these PCIe slots for the M.2s only take away from the SATA ports. Because if you've got PCIe drive here in 2.2, you'll lose one of your SATA 5, one of your SATA connections over here. So this competes with this. So these are competing with each other, but this, the Z490 does not have enough PCIe lanes to support Quadfire. I thought this said it was Quadfire capable. Or Quad SLI capable. Maybe not. Alright, so on that bombshell. Well, at least I know I got my my CPU dialed in for when it goes in my gaming system. So yeah, another setback in the road to getting Quadzilla going over here. Yeah, lots of time and effort to get not really going anywhere. So on that terrible disappointment, I'm going to go back to the drawing board and figure out what I got to do next. See you in the next one.